Hello, this is Benjamin from Eclipse. Today I'm with Christian Goetz from HiveMQ, and Christian is actually one of the co-founders of DC Square, a company who's done lots of work around MQTT in the past years, and I think actually Christian is going to do a quick intro to what they do. And Christian and his colleague Dominic, they really do a lot of stuff around MQTT. I can say that those guys are MQTT experts, which is why we invited Christian to do to tell us everything about MQTT, everything you need to know about MQTT. I think Christian has lots of tips and tricks for us. So Christian, without further ado, please feel free to go with your presentation and quickly introduce yourself.
Yeah, thanks, Benjamin. So I will quickly share my screen. So.
Okay, we see your screen. Perfect.
Okay, nice. So I will just put it to full screen. So can you still see my screen?
All good.
Okay, great. So hello everybody. Also from me, a warm welcome on this hot and sunny day. And thanks for being part of this virtual IoT meetup, which we will talk in the next, I think, 40 to 50 minutes about how to get started with MQTT. And if you have any questions about the topics I'm talking about or any other question around the topic, so I would ask you to tweet about the question with the hashtag of the virtual IoT meetup. And then we will collect these questions and I will answer them at the end. So I'm looking forward to some MQTT questions. So let's get started. So first of all, I want to quickly introduce myself. My name is Christian Goetz. I'm the CEO of DC Square, and my Twitter handle is at my last name, Goetz, CHR. So if you also have questions for me personally, you can follow me on Twitter or ask me anything there. A couple of times ago, I founded DC Square, and with DC Square, at the moment we build the HiveMQ MQTT broker, and we develop software solutions for customers, also around IoT and MQTT, but also on any other purpose. But at the moment, we mainly focus on building HiveMQ to scale up to millions of connections and improve the broker, so we can handle more connections and handle more throughput as well. So this is the field we are currently in, and we really love to work on HiveMQ because we get so much great respondents on this topic, and it's really great to work together with our customers to help them reach their customers over MQTT, for example, with chat applications and something else. Okay, this is about me and what I do, and I'm not just giving talks about MQTT in different conferences. So let's dive into a topic. What are the things, or what we talk about the Internet of Things, and we have a lot of different things nowadays, and these grow each day. So there are things like our mobile phones, our iPhones, but also other common stuff like cars, like logistic ships or logistic trucks, and also things from our everyday life, like medical stuff, like machines, like household goods. And all of these things are getting more and more smart. So they need some kind of way to speak to each other and to connect. But let's just first let's talk about what these things all have a little bit in common. So most of the things have constrained resources. So they don't have big data centers to compute, or they don't have much hardware or CPU or memory to use. So they're very constrained. They often use an unreliable network connection, and yes, nowadays mobile networks are still unreliable. Often they have to be built for low cost for the hardware to manufacture, and for the data plane they use to communicate over the internet. They often have no real or no steady power source and only use a battery. And often they have no home base, so they like a ship or something. They are on the way on the water, and they cannot just be connected to anything which recharges them or reads out all the data. So it's very interesting to have over the air or over the internet communication with these constrained and low power devices. Yeah. So how do these things talk? There are some requirements for that, or what things want. They regarding to their characteristics, they want slim and lightweight protocols. So if some I don't know, some weather sensor or temperature sensor which is out in the wild sends a lot of or needs a lot of bandwidth, then this will be a cost factor, and so it's very important to have lightweight protocols which transport the data efficiently. Also, important point is bidirectional communication. So devices need to send the data and also retrieve commands, and in order to operate or to configure them. They want to use as little overhead as possible, also because of the cost factor. And yeah, they hope the things or devices want not to think about duplicates, so they just want to send the messages and somebody else or something handle the duplicate automatically. And they really don't care about what's going to happen with the data they produce. So if you have a temperature sensor, the sensor reports its data, and it's the sensor or the application which is on the sensor is not really interested in what's happening with this data. They're just sending it to a middleman or middleware, and they are just then using this data to make some use for the end customer. So that's the points which things are interested in. And yeah, why not use HTTP? HTTP is a protocol we use since 1991 in the web. So it's basically birthed with the web and grown with the web. It's also widely known and adapted, so everybody or every programmer knows about it. And it has the request response paradigm. So always the client has to request to the web server, and the web server sends the response. And it's also just a point-to-point connection. So one client is talking to one server, and then the server needs to distribute the information any kind of way. So why not using HTTP? So often the thing is, it's really as we can see in the example here, it's example HTTP request getting the Wikipedia page. So it's quite verbose. So one thing is, it's often too verbose. You're sending too many metadata over the wire, and because it's request and response, every request has all the information in there you need to send to the server. Like for example, also the TLS handshake has to be done every time a new request is sent. So often HTTP is too verbose, or is just not suited, or the request response architecture is just not suited for the use case. And that's when we want a simple protocol, which can also do not only point-to-point, but one-to-many connections, which provide also kind of quality of service delivery, which is also a problem in unreliable networks. So we have to resend stuff. We have to care about has the endpoint successfully got the message or not, and also like lightweight and bandwidth efficient. And also an important point is data agnostic. So it should send every kind of data, which is also the case for HTTP. And it also should be continuous session aware. So when we have like very little devices, it's very helpful if the other side, like the server, is saving or storing some information about the client, which it doesn't have to send with each request. So that would be some criteria of an IoT protocol, which would be cool. And here's where MQTT comes in. So yeah, MQTT. I want to introduce MQTT a little bit and talk about these things, basic stuff, then all the features, some advanced topics, and then how to get started. But first of all, a quick introduction. MQTT is a lightweight networking protocol or application layer protocol. It was built actually. It's not so new as some or anyone could suggest, but it's from 1999, and it was first invented by IBM and Arcom, which worked on an oil pipeline project where bandwidth was very important. So they invented MQTT, and IBM used it for quite some time internally until they open sourced or they opened the specification in 2010. And then from there on, the MQTT, MQTT was more and more widespread and more commonly used by different companies. So we actually use MQTT since 2011, 2012. And in 2013 at Oasis there was some committee built to standardize MQTT, and successfully at the end of last year, MQTT is now an official standard at Oasis. Oasis is an open organization for advancing standards. So yeah, I think that's enough for the history. So let's dive directly into the basics and what's MQTT all about. Yeah, basics. So the biggest difference from MQTT to, let's say, HTTP or any other request response protocol is that MQTT uses a publish-subscribe pattern. I think the most of you will already know this, but I will just quickly give an overview of what publish and subscribe means. So let's take up the temperature sensor example again. For example, there is a temperature sensor out in the wild. And it sends data regularly. So it sends its temperature value, and there are two devices, one laptop and one mobile device, which are interested in this data. So and there's also the MQTT broker. So basically, we have two parties here. We have MQTT clients, which we see here 3 different clients. Like the sensor is one client, the laptop is one client, the mobile device is one client. All these clients have one MQTT connection to the broker, and they can do publish and subscribe. So this works like subscribing for a magazine. You just say you want to subscribe to, for example, I don't know, the Financial Times. Then you subscribe, and then they send you automatically the magazine when it's published. This is the same thing. The mobile device subscribes, for example, to a temperature value, and when the value is there, it gets it from the sensor directly. So this is the basic publish-subscribe paradigm. And in MQTT, we have, and the client can always be both. They can both at the same time, so it can be a subscriber and a publisher at the same time. Yeah, what's also important is that it's one-to-many, so the subscribers subscribe via topics, which we will see in a minute. They have a one-to-many delivery, so a lot of clients can subscribe to the same topics. Sorry, and then they get the messages which are sent over this topic. Also important is the different clients don't know each other. So they're just sending messages to the broker, and the broker is distributing the messages to clients which are interested or have subscribed for their topics. And every client, as I already said, can be both publisher and subscriber. So let's learn more about topics. So for our temperature sensor from the example, a topic would be my home, ground floor, living room temperature. So then I have a sensor in my living room, And the topics is built like a URL with different topic levels. And this is a core concept in MQTT, and it's very important because the routing of the messages is only built on topics. And it's also, of course, a component of each publish and subscribe message in order to the broker knows on which topic should this message be sent or which topic the client wants to subscribe to. So let's make a few examples and how topics can be used. So here's another example. It's the same topic, so we can just talk a little bit more about structure. So I already said the topic level separator is the slash, and we have different topic levels, which can be arbitrary value of different topic levels. And they're all separated with a slash. So if a client has to subscribe to very many topics, then this would be a little bit, you have to subscribe to every topic, and it would be a little bit of annoying. So there are wildcards in MQTT topics. So one wildcard is the single level wildcard, which is for one topic level. So with the plus sign, the client subscribes for any arbitrary level, any arbitrary value, which is appears in case of the plus. So for example, in this case, my home ground floor, I don't know, kitchen temperature or living room temperature or I don't know, any other room I would have on the ground floor is automatically subscribed, and I will get the messages for these topics as well. Also, the plus sign can be used more than once in the topic. So I can also do a plus sign except on the place of ground floor, and for example also on the for temperature. So I would subscribe to all kind of data which is published in the different floors in my home. Yes, and another possibility, if I want to subscribe to all hierarchies below, and I can use the multi-level wildcard, which can only be used at the end and subscribes to all levels which are under my home ground floor in this case. So this makes topics a very flexible concept, and every client who subscribes can use these wildcards. When a client is publishing, there's only allowed, there are no wildcards allowed. So the wildcards are only used at the subscriber level. Okay, so this is the part about topics. I think it's important to understand topics concept. It's not that complicated, but it's important to keep in mind when building your own MQTT application. So the second big point besides the publish subscribe is MQTT has a steady open TCP connection. That means MQTT is built upon IP and TCP and the OSI layer model. And this is so MQTT is application layer protocol, and it has the open TCP connection at any time. So each client has an open connection to the broker, and this allows a client to push messages to other clients, and they get it in real time or real time plus network latency. And this is a big advantage of MQTT. So you you don't have to poll for new data, but you can just get the data via push. And also an interesting fact is if a client connects from within a firewall, like for example a home router, then the client initiates the connection to the broker, and then he passes through a firewall, and then also the broker can proactively send messages to the client. So this is also a huge advantage if the application is located in behind the firewall. Yeah, so opening a connection in MQTT is pretty simple. The client needs to send a connect message to the broker, and the broker will respond with a connack. This is just and then the client is officially connected, and it can then send messages or send subscribe messages. So what's a connect look like? So a connect message has a client ID, which is the most important part, because each client has its own client ID, and this client ID has to be unique in order to identify the client, and also to identify the subscriptions the client has and everything else. Then there is also username and password, if it's in general optional, but normally this is used to identify the client and to authenticate the client. And there are also other stuff which we will talk later about last will and testament and keep alive. And also a clean session where you can say if the client wants to keep a session at the broker level. So this is the connect message. And we have also the connect, which is sending by the broker. It has a return code if the client is successfully connected or not. And if it's not connected successfully, then the broker sends some kind of error code like client is not authorized or any other error message. So then the client, if the return code is accepted, then the client can start subscribing and publishing. So the most obvious or most used operation is publish. So the publish package is very simple. You just have a packet ID, which is just a number. Then a topic, which topic you want to publish in a message, a quality of service, which we will talk about later, a retained flag, and the payload. The payload is just a byte array where you can pass any kind of data, for example, a JSON array, just a value, XML, or anything else, and also a duplication flag. But for a normal publish, it's only interesting to have the topic name, and the payload. This is the most important parts. The other things are for special or for MQTT features, which we will talk soon. Yeah, so let's look at the whole subscribing flow. So we have the publishing side, and now how do I subscribe? So the client, after it connects successfully, can send a subscribe command with the topic and the quality of service level, and then it gets us a sub-ACK back. So subscribe, acknowledge, and then when another client publishes something for that topic, the client will receive it. So a subscribe package looks like this. You can also send more subscriptions in one package. So it can be a list of quality of service levels and topics. So pretty straightforward. It's also one of the key points of MQTT to be simple and to be easy on the client side. So the client has just there's a publish and subscribe command basically, and connect and disconnect in order to do the basic operations. There are a few more, but we will talk about these in a minute. So this already were the basics. So we'll now go into the features which MQTT has on top of the basic communication to make it really useful for IoT, for example. So one of the big features is the guarantee of delivery. So there are different possibilities which can be chosen by the client to guarantee the different guarantee levels of delivery for a single message. So as we all have seen, each publish message has a quality of service. So the values are 0, 1, and 2. And when sending with a 0, this is at most once. So the publish is just sent to the broker, and if the publish is lost, then yeah, it's like fire and forget. If there is some kind of network failure or the mobile network disconnected, then the message will be sent at goodwill. But if there is something happening, then the message will not arrive. This is quality of service 0, which also has not a lot of overhead because it's just the message. And if you have a reliable network like local network or a wired network, then quality of service 0 is more than enough. When you have a mobile network, you should consider quality of service 1, because this is at least once. So this quality of service will ensure that the message arrives at least once on the broker. So, and this can be guaranteed by the broker sending a publish acknowledge. And if the client is not receiving this publish acknowledge in a certain time frame, it will republish the message. And this is where it also can happen that duplicates arise. Because when the pub/ec is lost, when the client publishes the message again, and the broker has no way to identify the duplicates. So it will pass it on to other clients. And also what's interesting here in general for publishers, there is this flow, like to send a publish to the broker, and the same thing happens with each client which is getting the message. So there is the first step is the client publishes a message to the broker. The broker decides who is getting the message or who has subscribed, and then sends the message to each client in the same flow. So if the client is subscribed to Quality of Service 1, the same flow will happen again between the broker and the subscribing client. This is the same. This is for all Quality of Service levels of all clients. This is the case. So if it's for most of the times Quality of Service 1 is used, it's also recommended to use it because it makes sure there is no message lost. And there's another level. Okay, here quick how the pub/ec looks like. So the pub/ec has just the packet ID in order to confirm the arrival of the message. So this is kept very lightweight. It's not sending the whole payload again. So the payload is only sent once to the broker, and the pub/ec is very simple, very straightforward. Okay, so let's look at the Quality of Service 2, which is exactly once. So this should be only used if there is happening something really, really bad, if the message is delivered more than once. Because as you can see, the flow is double the size of Quality of Service 1. We have 4 messages exchanged. And this is already to make sure that both the client and the broker knows that each other have received all the message. The exactly once delivery comes with a cost. But if it's necessary that it should only be delivered once and it's super important, and one should be used. This can also be determined by the client. So the client can say which quality of service it would like to use, and can choose the quality of service for each message. So this is very flexible. So let's look at the different packages. As you can see, they're the same as in Quality of Service 1. They're all very lightweight. There is no much overhead in the flow. This is really just the acknowledges of the messages. The whole information is in the first published package, which is the same for the other Quality of Service levels. So yeah, the other great feature is from MQTT is to buffer messages. So in pure pub/sub, there wouldn't be any buffering. So if the client is offline, it wouldn't get the message. This is often not acceptable. So there is some kind of queuing mechanism in MQTT, and there are basically two different possibilities. So first of all is to save or retain the last good value or less good message for each topic. So there's possibility to save the last message. The other thing is you can, each client can say to the broker they want to save, it should save all messages while a client is offline. So let's look at the two things. The first is the retained message. So there can be only one retained message for each topic. So for example, for a temperature topic, always the last temperature value is saved there. And if a client subscribes, the first thing it will, as soon as it's subscribed, it will receive this retained message. So without the client or the sensor have to send something, the client will receive the last retained message. This is very, very useful if there are some certain intervals which are messages are published. Then there would be a time frame where when a client connects, it wouldn't get any message as soon as it connects. But this helps the client to get the current status as soon as it connects. Okay, the broker will save this message per topic, and also a client can set the retained flag, and it can also leave out the retained flag, which will then the broker will keep the last retained message on the topic. and it will be delivered on the first subscribe. So the other thing is persistent session. So the cool thing about persistent session is it can store all the subscriptions from the client. So the client don't need to subscribe again when it reconnects. And the other cool feature is it queues all messages which are greater than quality of service 0. So as you can see in the example here, when a client connects with a clean session is false, with a persistent session, we can subscribe, and when it reconnects, it will automatically receive the same messages it has subscribed already, and will also get all offline messages which have been sent between the disconnection and the connection again. So this is a really cool feature because in general, MQTT is not like a message queue. It doesn't queue all messages. So it only queues when quality of service is greater than 0 and persistent session is enabled. Yeah, and also maybe it's good to know the topics are very lightweight. So you don't have to create a topic before you send a message. With queues in the message queuing approach, you have to pre-allocate a queue, and then you can send on this queue. So this isn't the case with topics. You can just start publishing and just without any registration. This is a very cool concept to begin with, and to save these messages or persist these messages when a client is offline. Yeah, the advantages are clear. You save bandwidth because you don't have to subscribe again, and no message gets lost even if the client is offline. Okay, cool. So another feature of MQTT is there are certain things built in the protocol which observes the client stages. This means often you have the problem that with connections which are with clients that are on a different location, you need to observe if they're online or not, and what's their current status, and yeah, that's the basic things. So MQTT has a keep alive. It is a kind of heartbeat. So each client on the connect message sends a keep alive value, and in this keep alive value, it sends a ping message to the broker, and then the broker responds with a ping response, and then both parties know they are still connected. This maybe could be maybe is seen as overhead, but when there is data sent like publisher subscribes, then the ping won't happen. So the ping only happens when the connection is without traffic. Then in every interval which the client can specify, the heartbeat will happen in order to prevent half-open connection problems, so that the broker thinks the connection is still open, but the client is disconnected. This can be prevented with that. At latest, on the heartbeat cycle, both broker and client knows, okay, the connection is not available, and somebody has been disconnected. There's also a small grace period, so the broker won't cut off the client after the heartbeat or the keep alive. There's a grace period with half of the keep alive. So 1.5 times after the keep alive, the broker will disconnect the client. And also MQTT has, for the same thing, the client takeover. So if a client disconnects and has a half-open connection and it reconnects, the broker will kick out the client with the same client ID, so the client can reconnect successfully. This is an important behavior for mobile use cases, because this is a real use case that can happen, and then the client won't be connected, won't able to connect again if the broker won't implement the client takeover. So this is also an important concept to handle the mobile use cases. Okay, then another feature is the last will and testament. This is a really cool feature where at the beginning of when sending the connect message, the client can specify a last will message and topic and quality of service, which the broker will send when the client eventually drops the connection. So this is perfectly suitable for notifications, for alarms when some clients are going down, and also for for knowing that the client has now or goes offline. So this can be quickly noticed with the last will and testament, and also the broker sends out this last will and testament message as for the client. So then it will be distributed to all subscribers which have subscribed officially to the last will and testament topic. So this is really cool to handle this kind of connection drops, and a really cool feature of MQTT. So this were the basic features, like a really quick run through. If you have questions on the features, you can first ask at the end, or you can read our MQTT essentials, which are on the -q blog. So when you go to -q.com/blog, there's everything about these features in more detail. So when using MQTT in production, when building up a system with MQTT, there are a few things you should keep in mind, and which I can only talk briefly about because there would be a own meetup for these topics alone. So the first thing is security. So MQTT can be secured on different levels. So you can just use a virtual private network, a VPN connection to secure MQTT, use transport level security or application level security. So there are different levels which handle the security, and you can also use more of them, which is also recommended. And yeah, for more infos, we have the MQTT Security Fundamentals series on our blog, which goes into detail into every thing here, because it's really a tough topic. Security is a tough and important topic, and it's totally possible to secure MQTT with the shown different kind of levels. And this is there is no issue with secure MQTT because MQTT relies on other already proven security mechanisms, like for example TLS or VPN. So, and also there are custom or individual authentication authorization mechanisms which let only the clients which are allowed can connect to the application. Okay, so another big or advanced topic is scaling. So scaling with one MQTT broker is possible, but it's really hard. Also, there is a single point of MQTT broker, a single point of failure. So you should at least have 2 or more brokers available. There are basically two approaches to that. It's clustering and bridging, and yeah, you have to think about what's the best solution. Clustering is so the client only knows one load balancer, and with bridging you just exchanging messages over pure MQTT. And in clustering, there is one cluster which shares all the messages and stuff between the cluster. These are two options. We will also write more about this topic on our blog. And the last topic is integration. So often MQTT broker alone is not very useful because it needs some backend services or backend application which process the stuff. So, and also to integrate with already built authorization services, for example, what each client can do. So integration is a big point which should be planned and explored very deeply or very thoroughly, because MQTT is suitable for connecting mobile devices to each other, and then you need, for example, for backend systems, you need to connect the broker to any kind of backend systems, because it's not not the best practice to have one subscriber as a backend system, because it would be highly overload for the client, for this one client. So this is also something which should be in mind, should you have in mind. Okay, so now we have covered the basics, the features, and the advanced. If you want to know more about the advanced topics, There are some good sources available on the web, also on our blog, on other blogs. And also, if you have any questions there, you can contact me directly on this. So we will switch over to getting started. Yeah, so we talked a lot of MQTT until now. So the important point is to plan what you're doing. So often people jump right in and start building topics and stuff, but it's really important to plan your topic tree. Also, if you want to scale to a high number of clients, to plan the server infrastructure you would need or you would expect you need. And also the software landscape, so what needs to be integrated into a broker for authentication, for authorization, for other, for processing the data. So it's really a very important to have the architecture right. So you should put a lot of thought in that and not start with MQTT coding right away. So it's really important to have this right. The next thing is, of course, building the application. And so now is the more interesting part. So we come to concrete client libraries and brokers. So when choosing a broker at the moment, there are dozens of brokers available. For example, Mosquitto, like -Q. Also, there are multi-purpose brokers available like RabbitMQ, ActiveMQ, Mosquitto, and so on. And there are many more on the URL specified here. So you need to choose. One broker. There are also public brokers available, which you can use for getting started and also trying MQTT out. For example, is MQTT-dashboard.com is one public broker, or also I think IoT.eclipse.org is another public broker. So you can just use that for getting going, and then use one of the brokers and install it by yourself. Just a quick excerpt from this list. So one of the well-known broker is Mosquitto. It's open source. It's very, very small and tiny, ideal for also running on constrained devices as well. So you can also run the broker on a constrained device. It supports bridging. It also supports MQTT over WebSockets in the newest version, which is really cool, and we will talk about in a minute. It's written in C, so it's very, very good for the most MQTT applications. In like if you build applications at home or for scaling to a few thousand devices. Then you also have, for example, -Q, which is built as a high-performance MQTT broker with security in mind, with high connection or high throughput in mind. We have native WebSocket support from the beginning, and also the open source plugin system, where you can write your own plugins and integrate the broker with your backend systems. It also supports bridging, supports clustering, and it scales way beyond 100,000 connections. Oh, I think there is Mosquitto here. This is a typo. So sorry. There should be -Q here. Yeah. So that's the -Q broker. You can find more information about all the other brokers on the URL on the slide before, and then there's also a comparison on that site where you can see which features are implemented by which broker. So when having a broker or simultaneously with the broker, you have to choose a client library. There are client libraries for all different languages like Go, Python, C, Java, all the Arduino, also JavaScript, which is not JavaScript is also not listed here, and almost all libraries have implementations. All languages have implementations of MQTT. So I want to just briefly explain one implementation is Eclipse Paho. It's the most well-known implementation, which has Java, JavaScript, C, and C#, .NET, and many more. It's open source. It's the reference implementation. Has a very active community. So this is also quickly some code. So opening an MQTT connection is pretty simple. You just specify the host name, the port, and the client ID. And then you can connect, and then just publish a message, and then disconnect. This is a very simple example. For this, And yeah, of course, one of our newest projects is the MQTT client Encyclopedia. So each of the plugin of the client library maintainers will write its own about its own library, and we will publish all the stuff on the -q blog under the MQTT client Encyclopedia series. So if you just getting started with MQTT or want to get more info about the client libraries, that will be soon on the -q blog. So I hope you enjoy this series, because many people ask us about using different clients, because there is no standard guidelines for this, and so we want to just build up one. Okay, great. So we have been through the basic steps, so basic things you need to get started with MQTT, and now I want to show a quick demo. So I will just share my entire screen if that works. Just one moment. So, okay. I hope everybody can see my screen.
Yep.
Okay, great. So then I will just start with that demo. So the demo we have using MQTT or WebSockets. This is a very cool thing where MQTT is packaged in WebSocket frames. So even the smallest sensor, which is out in the field, can publish data to each web browser. So there's a directly or live stream, you can live stream the data from a publisher to the web browser. And we will look here at our publisher. This is, make it a little bigger. Okay. So we have the Paho client here again, and it will just publish, here we publish the temperature every few seconds and just use a random value. And we can also see this on the console, so we can see here, okay, we publish this random temperature values which are just generated. And then we have the MQTT broker, we have -q running in the background, and we have a dashboard. So a web dashboard which is using, I hope you can see now, which is now using MQTT over WebSockets and showing these values here. So when I can maybe do both on the same screen. So whenever a new value should be published, it should see this at the same moment on the screen. So we have 38, and now we see the new temperature. We have now 40, 42, and so this kind of data, this kind of program, this sensor is just a simulator, but this would run on the device, which sends data to MQTT broker, and the web dashboard also subscribes on this dashboard, on the broker, and will get the data instantly. And also there can be any other kind of services using the same topics to subscribe, and yeah, you can get the same data and can also display it in any kind of other way. So mobile clients, web browser clients, or FAT clients can use the same data by just subscribing to the same topics and being totally independent of each other. Okay, so this was basically the quick demo. I hope I could show you the most important things about MQTT. This is really so many things to say about this protocol, but I hope I talked about the important points. More extensively, the stuff is on our blog, and you can, I think, if you are interested in the stuff, then it's best to go to mqtt.org or the -q/blog and to read the stuff there, because this, I think this webinar was pretty packed with stuff, and I hope it should give you guidance on which are the important topics to consider, and then you should take off from there and choose what's best for you. So thank you very much for watching, and that was pretty much my presentation I have prepared. And here are just the links I just talked about. And yeah, I'm happy to answer any relevant questions, if there are any. Benjamin?
Very cool. Actually, there is one question, but I hope more will be coming. Feel free to ask your questions on the Q&A section of Google Hangouts, or tweet them, add them to the comments on the Google Plus event. Yeah, the question we have, but I think you've covered that topic. Maybe you can elaborate a bit more. Question is from Edgar. Can brokers subscribe to other brokers?
Okay, so yeah, of course. So let me, oops. Just will stop the screen share for a moment. So can brokers subscribe to other brokers? In general, they cannot. They cannot subscribe to each other, because a broker is yeah, a single instance. There are possibilities to transport data between brokers. So it would totally depend on what is the use case behind this. So if the use case is just exchanging some kind of messages, then maybe bridging would be the right thing to do. So bridging is just the broker has an MQTT client built in, which then subscribes to the other broker and publishes or subscribes to data. This is one option. Or when just in kind of scenario where it's about scalability or availability, you can also use clustering. When the broker supports this, this will then talk. The brokers will talk to each other on other kind of protocols internally. So these are the two use cases where broker can talk to each other. If there is a specific use case which this behavior is needed, you can please write an email or Twitter or write me a Twitter, and we can discuss this in more detail. I think these are the basic things to say about this.
Okay, so I don't see other questions. Maybe we can wait for a few more seconds while I do the announcement of the next virtual IoT meetup, which is going to be in 3 weeks on the 23rd of July, same time, and it's going to be about programming IoT gateways in JavaScript using Machina.io. So we've been covering JavaScript a couple times in our past meetups and hangouts. So hopefully you can learn more about how to program gateways and not only microcontrollers and sensors using JavaScript. So make sure to RSVP on the meetup event to be notified in time. We don't know yet what we will have in August, but I expect we will be slightly less busy, so maybe one meetup in August, and then we will be back with a more regular schedule in September. So still no questions. So I think Christian has been pretty clear about the ways you can contact either HiveMQ or Christian on Twitter and or on their blog. Feel free to direct any questions you may have to Christian. I'm sure he will be glad to answer them. So Christian, thank you again. I hope you will be uploading your slides on SlideShare, maybe.
Yeah, of course.
Okay, good. And well, as always, the webinar is being recorded, so it's going to be available on YouTube straight away.
Okay, great. Thanks, Benjamin.
Thanks, Christian. Bye-bye. Take care.
Yeah, bye-bye.